Yeah, hello everyone. We are in the chapter section 2.4, set theory, surveys and cardinal numbers. Okay, this section has deal with different surveys, and also in the end it gives the cardinal number formula. So it consists of three parts: analyze survey results, apply the cardinal number formula, and interpret information from tables. Okay, about tables, I will tell you a little bit so in the very end. But first, I want to start with something different: how to put different elements in the Venn diagram. We didn't do this yet, so this will be the first one. Okay, I put three different documents: modulo 5.1, modulo 5.2, and modulo 5.3. This is about Venn diagrams, how to put the elements inside the Venn diagram, and how to shade different regions on the Venn diagram. So we start with modulo 5.1. Module 5.1. Okay, this is let me just write two sets. Okay, I show you how to put elements in two sets. Okay, so consider the following picture. Okay, that one is the universal set U. Okay, write it down. Universal set, and here we have set A and set B. Okay, I just remind you what are each part. So we have 1, 2, 3 parts inside A union B, and one part is outside. So that part in between is called the intersection, A intersection B. So that one is intersection. Okay, in the book, letter I is written, but I prefer in mathematical books, the sign is that one. It's upside down, U upside down. Okay. So it's intersection, common elements, both. Now, this part is A minus B. The elements which are in A, but outside of B. So you see these elements are outside of B. And likewise, the other part is B minus A. These are the elements in the part B, in the set B, but outside of A, that do not belong to A. Okay, now we consider a particular example of this set. U equals, set U is called universal set. Universal, okay, I will not write it down. Okay, and consider the following U. It consists of the following elements: A, B, C, D, E, F, and then numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so how many elements are total? 10 elements here, and this we have 6. So total 16. So you can write N of U equals 16. The number 16, okay, maybe it's not C. Let's write here. N of U equals 16 elements. Total. Okay, this is U. Now I I will tell you what is A and B. A is the set consisting of the following elements: A, B, C, 6, 7, 8, 9, then D, E, 4. Okay, let me erase the number of elements. We've already calculated, so that would be so 4 and 10. Only some part of the elements. B is the set A, B, C, 6, 7, 8, 9, 5, 1, and F. Okay, so the question is, we have to put the elements inside the sets A and B. Okay, we have to draw the Venn diagram, so then put elements in the appropriate places. So that one is A, B, U. Okay, how to start? We have to start from the interior part, and then we go outside. So first we put into A intersection B. What is A intersection B? Common elements. What are common elements? Let's look. A, B, C, 6, 7, 8, 9. A, B, C, 6, 7, 8, 9. I put in special way so you can see it easily. So this part and that part is the same. If the elements are mixed up, you have to check. For example, A, E, so I take first element A. Is A in B? Yes. So therefore we mark it. B, B, C, C, 6, 7. Now let's take D. Do we see D here? No. So D does not belong to B. D belongs to A, doesn't belong to B. And so forth. And all the others, D, E, 4, and 10 do not belong to B. Likewise, 5, 1, and F belong to B, but do not belong to A. Got it. So therefore, first what we have to do, put the common elements. Now let me just write it down. So it's A, B, C, 6, 7, 8, and and 9. Okay, so A contains these elements and B contains these elements. Okay, I hope everything is clear and seen. Okay, now after that we have to put elements in A which are not in the intersection. Okay, so that is the intersection.
Yes.
So what is in A?
DE 410.
DE 410. So DE 410. Actually, I have to put points here, meaning the elements with that label. Okay, but I just write on the labels. It's clear, right? DE 4 and 10. So 4 elements. Now next is 5, and next is B, which are not in A. 5, 1, F. 5, 1, F. Okay, so I filled A and B, so I filled A union B. What else is left over? Let's look. Okay, let's look. How about what else? So, okay, 4 is there. So how about 1? 1 is there. Yes, 1 is in B. How about 2?
2, no.
Okay, no. So we just mark it, and we put 2 somewhere outside of A and B. No, suppose here 2. Next, what else?
3 is not
3.
there either.
Yeah, so 3 as well. So I write 3. And now let's, after that, if we want to check if everything is filled, we have to go along the U and just go from left to right and check if all the elements are already used.
Mm-hmm.
So A, B, C, D, E, F are used. Yes, right?
Yes.
D, E, yes. Okay, 1, 4, 5, 6, 7, 8, 9, 10 are used in here in the A and B inside of these two circles, and finally 2 and 3 are outside. So therefore we are done. We filled everything, and the question is how to write it down. So what is now? Let's write the intersection. What is intersection? A intersection B. This is A, B, C, 6, 7, 8, and 9. You can write this even without the Venn diagram, just marking the common elements. But if you mark them, and if you put in the Venn diagram, you will see that immediately, clearly. It's much easier to see. Now, please tell me what is A minus B. What is this set? The elements which are in A, but not in B. What are those? Elements in A, but not in B.
That would be DE 410.
DE 4 and 10. Yes, exactly the elements which are in here, right? Which we put there. Okay, now in B minus A is, you write curly bracket. And what are the elements? So look at the diagram, it's
So
much
it'd be
easier.
5, 1, and F.
Yes, 5, 1, and F. Good.
Minus DE 410.
Okay, so that's it. Pardon me, what did you say?
Minus DE 410? Or minus A? Right?
No, A, no. Okay, so I'm talking about B minus A. B minus A is this part.
That is right.
Okay, look here. This is that one. What is outside of A, but inside of B? Okay, is it inside of B? Yes.
Yes.
5 on, but outside of A? Yes.
Yes.
Because outside, yes, it's not. And A, B, C, 6, 7, 8, 9, both, they are both in A and B.
Right.
Okay, and together, simultaneously. Okay, likewise DE4, they are in A but outside of B.
Right.
Okay, good. So therefore this is that one. And now how to describe 2 and 3? What is 2 and 3? They are outside of what? If we take all elements 5, 1, F,
They're outside of A and B.
yes, outside of A and B together, how to write this down? Okay, you have, if you write A union B, it will be all the elements inside these two circles. E, D, 4, A, B, C, 6, 7, 8, 5, 1, F, right?
Mm-hmm.
But those two are outside. So therefore it's U minus these two circles. If I take scissors and cut out of these two circles together, what's left over? 2, 3. So 2, 3 is in complement of A and B inside U. You can write U minus, let me just write, equals U minus A union B. A union B is together. Okay, how is it called? You know, remember, if some set is removed from U, do you remember how is it called? Okay, this is just right prime. Prime is complement.
Right.
Okay, remember this letter is E. Yes, if you write I, it will be complement. If you answer correctly, it will. I'll give you a compliment for that. But that is complement. Okay, so 2 and 3 are outside of the union. Union is shaded here. Okay, got it?
Yes, I do.
Okay, now it's interesting thing. So I want to erase, okay, because I see the Venn diagram, I do not need to draw that one. I don't have enough room here. I want to continue, say something here. So let me erase this part. And let me erase everything because the whole picture is reflected here. I know where is, which elements are where, and I know everything. That's why the Venn diagram was created. Okay, so instead of looking at this list, I know the whole picture. Now, question. My question is this one. What is, okay, we wrote A intersection B. A intersection B is A, B, C, that number 6, 7, 8, 9. How many elements are in A intersection B?
Well, wait, A, B, C,
Right?
6, 7, 8, 9, D, E, 4, 10. Correct? No, am I wrong?
No.
Oh, it's just
Intersection,
A, B,
all-
C,
Yes,
okay.
only here, yes, only here. This is the
I confused the
intersection.
question.
Yes, so how many elements are there? Count them.
6.
No.
Wow. For 7?
7. 1, 2, 3, 4, 5, 6, 7.
Mhm.
So we just try this one. It's called cardinality.
Mhm.
Cardinality. Cardinality of this set, the number of elements. Cardinality. Cardinality of A intersection B. Okay, the cardinality. The cardinality. Okay, 7, the number of elements. Okay, now it's, tell me please how many elements are in A minus B.
Okay.
Yeah, call them and then say how many.
D, E, 4, 10, which
Yes.
means there are 4
D, E,
elements.
4, 10, correct, 4 elements. Now n of B minus A.
3, 5, 1.
Yeah, 5, 1, and F. So it's how many? 3. Now it's interesting question. So what is the number of elements in A union B? Okay, total number of elements. How to find that?
7.
No. Total, okay, what is A union B? A union B is the whole thing. So this one is A union
Ah.
B.
Okay.
So if you start adding, if you start counting together, it will be
14.
okay, but yes, you have to add those because they do not intersect.
Gotcha.
Okay, that set, this set, and that set, okay, this, that, and that do not have anything in common.
Mhm.
No common elements. So it's called disjoint union. This, that, and that, union. Disjoint means no common elements. So we have to add those. It will be 7 plus 3, 10, 14. Okay. Okay, now it's next question. What is n of A itself? How to find this? Okay, A minus B and A intersection B. So we have to add these two numbers. Let's look. A minus B and intersection. So 7 plus 4. Hold on, let me just write it. 7 plus 4. Clear?
Yes.
Because they do not intersect. This set, okay, this set consists of A, B, C, 6, 7, 8, 9, and D, E, 4 in the other part. They have no common elements. That's why I add this and that. 4 and 7. Now, what is n of B?
It's 7 and 3, right?
Yeah, so
Plus
this,
3.
let me just write down. So here we have 4 elements, this you have 7 elements, and this you have 3. 7 plus 3, right? 7 plus 3, it's 10. Got it?
Yes.
Now I will show a very interesting thing. Okay, let's look 14. How did we get 14? You see, if you add all these numbers, you get, you get 14. But if you add, so what is 14? 14 is n of A union B. Okay, equals, suppose we write this one, n of A plus n of B. Suppose we write this one. Is it true or not? If you add those, you'll get 21.
Okay, so no.
But it must be 14.
So no, it's not true.
Yes, so we have to, this is 21. So we have to subtract
So
something.
they get 14.
So how many elements we have to subtract to get 14? So this
we'd
is
have
14
to subtract. We'd have to subtract n 80
from 21. Minus 7. 21 minus 7. Oh, yes, 21 minus 7. 7 plus 14 is 21, right?
Mm-hmm.
Okay, 7. Okay, now let's look. Do we see 7 somewhere here? This is the case, yes? This is the intersection. So we just write minus 7. Instead of 7, we just erase that and write N, A intersection B. So we got a very interesting result. We got the following, 14 equals 11 plus 10 and minus 7. Or let us write the formula. N of A union B equals N of A plus N of B and minus N of, let's write here, minus N of A intersection B. Minus N, minus the number of elements inside B. So it's interesting. So A has 11. So how many? A has 11 elements. B has 10 elements. The cardinality is 11 and 10. And that one, and this one, has 7. So therefore, how do we find the total number of elements? If we add all these numbers, no, if we add 11 and 10, we'll get too many. Why? Because these elements will be counted twice. That's why one time we have to remove this 7. So 11 plus 10, if you add them up, so how do we do this? So what is 11? This, that, and common part. How do we get 10? This 751F and also common part. So common part is counted twice, but we have to count only once. That's why one time we have to remove. That's why we subtract 7. And so we got, so this is the arithmetic, and that one is the formula. Okay, this is the formula, the cardinality formula. The cardinality formula. Okay, so do you see in your paper, on the back side, I think on the, yeah, you see it? 14 equals 11 plus 10 minus 7, and this is the cardinality formula, but I wrote here the cardinal number formula. Okay, got it?
Yes.
So now you know how to find the total number. Remember, so imagine that you color A in red, say B in blue.
Right.
Okay, this part will be colored in blue and red simultaneously because it's common. So what is the total number of paint you used? We used that amount of red, okay, this amount of blue. But actually, in the common part, you have a 2-layer of paint. So one time you have to remove. That's why you have to subtract common part. So this plus that minus common part. In which case you can add without intersection. Only if the intersection is empty. So if you have two, okay, let me draw here. Suppose you have this A and that is B. Okay, how to find the total number of elements? Of course, you have to add this number, okay, this N plus that M, right? No common intersection. Or using this formula, N plus M minus intersection. But intersection is empty, 0. So you subtract 0. That's why you add. Got it? Okay, so that formula is very easy, and now we learn in very simple way how to put elements in the diagram. Okay, now that is easy. Okay, now we go to the 3, to the modulo 5.2. Okay, take another paper, modulo 5.2, and now you have 3 sets. Okay, I erase everything.
Oh no.
Hmm?
I said, oh no. 3 sets.
Yeah, okay, 3 sets is much more complicated. And that's what we have to learn. And we do this in the same way. We just work in the same simple way first, and then we'll find the formula for the cardinality formula. Okay, the first part is called part 1 and this part 2. Okay, part 2, 3 sets. I will not write it down. In the paper it's written part 2. Okay, let me just write the sets, almost the same sets. Okay, U equals, okay, do you see the sets in your paper? Okay, let's write A, B, C, D, E, F. Then numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This time it's more, a little more, 11, 12. Okay, A. A is A, B, C, 1, 2, 3, 9, and letter D. Then B, A, B, C, D, E, 1, 2, 4, 5, 6, 9, and 10. And finally C, you see much more different combinations could happen. So A, B, 1, 7, 8, 9, 10. Okay, and I draw, okay, 3 circles. Call them A, B, C. Okay, please write down all the time in that way. A on the left side, B on the right, and C is below. So, what do we do? How to put these elements? If you put them arbitrarily, you'll get a contradiction. You will be completely upset, completely confused, and the work will not be correct. So first, what we have to start with is common elements. Okay, let's find common elements. Okay,
6.
not 6, elements.
Oh my god.
So let's look A and underline them. A is in A, also in B, and also in C. So we underline them. Okay, next B also is here. How about C? C is in A and B, but not in there, so it's not common element. Okay, got it? So let's go further. 1. 1 is in A, I see it in B, and I also see it in C, so it's common element. How about 2? 2 is in here, but 2 is in A and B, but not in C. You see that? Okay, now next 3. 3 in A, there is no in B, and you do not need to look in C. 9 is here in B and C. Okay, 9 is common element. So 9 is common element. Okay, got it? So look at the board. And so we underlined all the elements which are in common. So we have to write them down. A, B, C, 1, no, not C, sorry. C is not underlined. A, B, 1, and 9. Okay, what is the cardinality? 4. 4 elements. Okay, good. Okay, next. Okay, next, which part would you fill? Okay, so look at the board. There, look at the board. So which one we have to fill? Okay, so now we have to take A intersection B. Okay, we know some part of that. Okay, but we don't know what is here.
Okay, so A intersection B is just the lower part. Or am I getting
A,
that
no,
wrong?
A, B, 1, 9 is the common part of A, B, and C
I see.
simultaneously.
Okay, never mind, I'm sorry.
Okay, now we go this one. That part belongs to A and B. So first, okay, find what is A and B. Don't look at this common part.
Gotcha.
Okay, this common part. Okay, this common part is intersection of the 3. Let's write it down immediately. A intersection B intersection C equals A, B, 1 and 9. Okay. Now we find A minus A intersection B. This part is already filled.
Right.
So what's left over? Now we just don't look at C and look only A and B.
Okay.
What are common? So now you see that C is common.
D
C is common. Let's write. Okay, so we look C. So let's write C. Otherwise we'll forget it. Okay, C. Now what is 2 is not, 3 is not, D, or D. Also D. And that's it, I guess. Or maybe something else.
2.
Yeah, 2, right. Okay, 2. So therefore we'll just write C, D, and 2. And now we know what happens in A intersection B. Let's write it down. Please dictate me what is A intersection B.
A intersection B.
The whole thing, yes. What
It
is
is
that?
E3.
No, just
C.
look at the picture. You have to call all these elements. So A intersection B. This is A intersection B. So you have to call all these elements. First call elements inside. So in the middle part. A, B, A, B, 1, 9, and then continue C, D, and 2. So this is A intersection B.
Okay.
Got it?
Yeah, I think so. I think
Yeah.
so.
Okay, so look at the picture. A intersection B is this part. If you remove C, it will be the same picture as we had before.
Mm-hmm.
Okay, so this is that one.
Yes.
Now, okay, which parts of the same kind are not filled yet? This part and that part, look. This part and that part. So that part is called A intersection, okay, A intersection C. A intersection C is this loop. Call it loop. Okay. Partially is already filled. AB19. Now we have to put in here. What is that?
Nothing.
No, so far nothing, but maybe it will be something. Maybe nothing. Okay, let's look. A and C. Okay, A, B, okay. Let me just, by the way, so cross common elements, otherwise they, okay, so cross, we just found the A, B, 1 and 9. 1, 1, 1 and 9. I don't want to, all the time, so all the time they are used in here. I don't want to look at them anymore. A and C. After that you look what is left over. Okay, 2 and 3, 7 and 10. Nothing here, you are right. So we write empty set here. Nothing. Now let's look at, so let's write, so we have A intersection C. Now what is A intersection C? Tell me please. What is A intersection C? A intersection C consists of empty and A, B, 1, 9. So we just write A, B, 1 and 9. And you see that this is the same as A intersection B, intersection C together. Okay, good. Next is B intersection C. B intersection C. And what is that? Now we want to get this part. Okay, let's look. What is common? B intersections. Find common element. Okay, E is not here. 4 is not. 5 is not. 6 is not. 9. Oh, 9 is already okay. We crossed. 9 is not. 10. How about 10? 10 is here and 10 is there. So let me mark like this one. So therefore this is 10. Got it?
Yes.
Now what is B intersection C? The same common part as before, A, B, 1 and 9, and also 10. 10 is not inside this part, it's outside, but it's inside B and C, inside this loop, so inside this ellipse, I would say. Okay, so therefore what's left over? Left over this part, that part, and that part. So what is this part? This part, elements of A, which are not already put inside circle A. Now we look at circle A. C, D, 2, A, B, 1, 9 are here. So what we didn't put yet?
3.
2 is already there, so 3. That's it? Oh, maybe I wrote incorrect. So what is A? Oh, I'm sorry. Actually, in my paper, I forgot to write letter E here. So letter E is not. So let me put E in here. So anyway, yes, letter E. Then it would be in B and A. So where is letter E? I think I missed that. Okay, so it's my mistake. I think it's E in here and also in B. But not in C. So I have to put, okay, please make this, okay, that is incorrect. So I have to write E in here. Please write it down, Darren. Put E in here. Because I missed it. When I rewrote this, I wanted,
Okay, because I was
I
like.
kept this one, this E and that E.
Mm-hmm.
Let me just try this one.
Okay.
So E and E.
Okay.
And I have to put it in here, not inside this part.
Let's see, can I just X out the 3 and A? I mean the E and A, my bad.
Yeah, so this is E, small e, and that, it lies in here. So therefore A, the other part is only 3. And please cross in the picture, so erase E.
Mm-hmm.
Okay, cross E. So it was E here, but okay, we cross it, okay, we erase it. Only 3 is left over. Now what in the set B?
4, 5, and 6.
Yeah, 4, 5, and 6, right. What are in C, but not in A and B?
7, 8, and 7, 8, 7, and 8.
7, 8, no, and something else. Maybe I also missed.
Oh, whoops, 7, 8, and it says F in the diagram, but I don't see.
Yes, in F in diagram.
But then, wouldn't F be out of all of them?
Yeah, so erase. Okay, so it was written F here, but okay, please erase it and add it to the other part of U.
Yeah. F would be a part of 11 and 12.
Yeah, so 7 and 8, so I have to cross it. Unfortunately, some small mistake. So F is not here, but F is in there and E is not here. So F should be added. F should be added to the. So F is not here. Okay, are you with me?
Yes.
So F is not here. Okay, so that's it. So we finished filling A, B, and C, and now what we have to do is to fill in the whole part. So that should be rectangle. In the beginning, you have to draw rectangle as in my picture.
Right.
And so what's left over?
11.
11, 12, and now F, right? So therefore, you see, they belong to the other part. Now, if I ask you, yeah, so because I made mistakes, I wrote some conclusions incorrect. So what can you say about, for example, okay, 7 and 8? What is that? How to describe the subset 7 and 8?
Oh, no, 7 and 8 is a part of C, so wouldn't it be C?
Yes, C, and minus,
C
okay.
minus A
Union.
U B.
Yes, A union B. So if you take scissor and remove this part, the whole, it will be C minus A union B. Okay, do I have enough room? Let me just erase this part. Okay, so 7, 8 is just C minus A union B. Okay, important thing to write is to write parentheses.
Mm-hmm.
If you write the other way around, C minus A and union B, it's not clear what do you do first. It looks like C minus A.
Right.
If you write C minus A and then union B, it will be absolutely different result. C minus A, okay, C minus A is this part, that part. And plus B, it will be the big part, okay, big part, absolutely different. Important thing is to write parentheses correctly. Okay, once you subtract some set, consider this as a whole and put, okay, put the parentheses. Okay, 7A. For example, how would you describe 3? It's inside A, right? A, but we have to remove all the other part. A minus B union C. Okay, B union C is this part. If I remove it, I'll get only 3.
Right.
Because inside A.
Okay, no, I get that.
Okay, you got it? Okay, now I erase this one because everything is reflected on the Venn diagram, and instead of formulas I can look at the picture. Could you tell me please what is that? What is F, 12 and 11? What is this set? How to describe it?
These elements would be a part of a set.
It's so that one, the whole thing is U.
Right.
Okay, so you have to describe what is in U, but not in A, B, and C.
Oh.
A, B, and C is union,
So this be U equals.
not equals. I have to describe this part.
Oh.
Okay, I have to take A union B union C. Okay, look, and remove it. Okay, when I remove, I just write prime, which is the same as U minus that union, A, union B, union C. Okay, union, it means that all the 3 parts, so everything is shaped. We'll work with that a little bit later. Okay, now, after that, if you write the number of elements, so what is how many elements in A?
1. No.
1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 9 elements.
9. Okay.
How many elements in B?
1,
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this is 11 elements. I circled. This is not an element, it's number of elements. And how many elements are here? 1, 2, 3, 4, 5, 6, 7. 7. If you add them up, 7 plus 9 plus 11, you'll get much bigger number than the total number. So how many elements are altogether?
27.
How many?
27.
27? No.
No?
Okay, let's look. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Only 15.
How did I get 27?
Because
I added
because
the
you add
numbers
those,
together.
yeah.
I added
So
all the numbers
15.
together.
But you said you add 9 plus 7 plus 11, right?
Yes.
Okay, it's not true. Okay, let's count once again. I want to get exactly. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Correct. So that number is 15.
Right.
So what happens, why 9 plus 7 plus 11 is much bigger? It's what? It's 27, much bigger. Why? Because we counted some numbers several times. So that one we counted for A and for B.
Right.
So we have to subtract what? We have to subtract 1, 2, 3, 4, 5, 6, 7, 8. Minus 8. Also, this part, B and C, is common. So we have to subtract 1, 2, 3, 4, 5. Minus 5. And also we have to subtract here 1, 2, 3, 4. Okay, let's calculate. So what do we have? This is 27, right? 27 minus 8. 19 minus 5.
Ooh, 14?
14 minus 4.
10. 14 minus, yeah, 10.
Oh, I think we made some mistakes. So this is
Probably.
27. Okay, once again. Let's look how many. 1, 2, 3, 4, 5, 6, 7, 8. 8 is correct. Now, 1, 2, 3, 4, 5. 5 is correct. And this one is 4. Okay, did you come correct? 27 minus 8, 19. Minus 9 is 10. I think, do you know what? I think because, so something wrong in here. So element F is in here. Oh, I see. So it's 3. Let me check my diagram and the one D2. Okay, so you see letter E. Where is letter E? I put letter E in here. Letter E belongs to, I think I have to remove this word. So letter E belongs to A and B. Yes, it's put on the correct place. 3. And this is F. 7, 8, 1, 9, okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's correct. This one, 1, 4, 5, 6, 7. 7. And this is 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is 12. 12. It's not 27, it's 28. Okay, let's check once again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 4 and 4, 8, 9, 10, 11, 12. Yes, 12.
Okay.
Yeah, so that's a mistake. And now, okay, 28 minus 8, 20 minus 5, 15 minus 4, 11. But this is 15. So when we subtracted too many.
Right.
And what we have to add to get 15?
1.
4. 4. This is 28. Okay, this part is 17. So difference is 11.
Okay.
11 and plus 4 will be 15. What is that for? This 4 is actually this part.
I see. Okay.
Okay, got it? So now we get a very beautiful formula, which I want to write it down immediately. I erase everything and write the formula, cardinality formula. Okay, it's more complicated, of course, than formula for 2 elements, for 2 sets. And this is that one. And if you want to find n the union, okay, like we did. First, what we have to do, we have to add how many elements in A, how many elements in B, how many elements in C. That's what we did. And we got 28. And that's right here, it's 28. But it's too many. So now we have to subtract the double intersection. A and B, A and C, and B and C. So we subtract n of A intersection B, subtract n B intersection C, and also A and C, minus n A intersection C. And that gives us how many? 17. So we have to subtract 17, we get 11. And you see, when you subtract it, okay, we subtracted the middle part 3 times. But we have to subtract only 2 times. That's why 1 time we have to add. In the end, you have to add A union, so A intersection B intersection C. Okay, got it. So therefore, if you know the number of elements in each set, in each circle, and you know in the double intersection and know in triple intersection, the formula is add the numbers in the circles, too many, subtract double intersections, okay, it will be 2 less, and add the interior part, the triple intersection. You see, for 2, okay, let's compare with this formula for 2. For 2 you have A union B is n of A plus n of B and minus n of A intersection B. So we just added this one, and to be so intersection part is counted twice. One time we have to remove. This is the same. We add those three, subtract double intersection, but there are three double intersections.
Mm-hmm.
See, 1, 2, 3. Because of that, we subtracted too many.
Right.
So we have to add one thing which we subtracted too many times, and that will be it. Okay. So this is it. Now we go to the model of 5.3. It's shaded regions. Okay, I erase. Okay, 5.3. Okay, shaded regions. And I clean the blackboard. Okay, that is the most difficult part because you have to figure out what to do. Okay, so first of all, let's start with two sets, A and B. I want to shade the intersection. So intersection will be this one. So I write A intersection B. Next is, what is that part?
A minus B.
Yes, A minus B, right. Okay, remember I put minus a little bit inclined, not like in arithmetic, just because it's set here. But you can write minus in normal way if you want. Okay, next is the Y key.
Yeah, it's about a streak on the board.
Oh, it's too wet. Okay, next is if I take A and B and take this part, it will be B minus A. And finally, if I shade everything, A and B, it will be A union B. Okay, got it? So now you know all the four possibilities.
Mm-hmm.
Union, minus, one minus, another minus, and intersection. Common part. Okay, so in the picture and model 5.3, I separated the whole picture as follows. So A, okay, that part, okay, this picture. So the whole thing equals A minus B intersection B minus A, and then I have to write the union. So this one is equal to that A union B equals A minus B union like plus, okay, like we add A intersection B, the middle part, and add B minus A. Okay? So this is a formula. This is the union, disjoint union of three sets. These sets do not have a common point. A minus B and B minus A have no common point. A minus B at the intersection B have no common point.
Okay.
You got it? So here, this point is not here. This point and that point are different.
Okay, I see.
No common points.
I see what you're saying.
And this one is also. Okay, you got it? So this is the picture. Okay, now with three sets, it's much more complicated, and I'll try to tell. But okay, before finishing that, let me just take this one. Okay, that set. So this set together. So this is A minus B. This is B minus A. And if I surrounded by parentheses.
There would be a common point.
Okay, not the common, the outer part,
Yeah.
so this is A, this is B, outer part, everything, so this is the same as A union B, everything, minus the middle part, minus
Okay.
A intersection B,
So
right?
the only way there would be a common part is if A and the intersection are both shaded in, correct?
Say again, say again.
So the only way that there would be a common part would be if either A or B is shaded in along with the intersection. Do you get what I'm saying? Yeah. Like
so
if
maybe-
A and B were shaded in, but B wasn't. No, if A and the intersection were shaded in, but not B,
So it will be A,
it would just, okay.
it will be A, you see this will, so this part and that part,
Yeah,
so this part is A.
okay.
And if you take this part, this will be B. And that is what is in common, A intersection B.
Right, okay.
Got it? So this is the whole thing is A, look, A.
Mm-hmm,
This is B,
correct.
this is intersection.
Gotcha, alright.
But now it's interesting, I remove the middle part.
Mm-hmm,
And if I remove the middle part, I'll get this part.
yeah.
Okay, and you see,
Alright.
if you compare A minus B and B minus A, they are not equal.
No.
But in this case, okay, that one is called symmetric difference. It's called A delta B, A delta B, delta, okay, equals B delta A. Because it's, if I pronounce first A delta B or B delta A, I'll get the same picture.
Right,
That's why it's the same.
okay.
So that's why it's called symmetric difference, symmetric, because symmetry. If I change those, I get equality. So A minus B is not equal to B minus A, but A delta B equals B delta A. So this is two sets. Now I consider three sets. Okay, three sets. Okay, we considered that before. And if I, so A, B, and C. How many regions do we have? 7 regions. One, okay, starting from the periphery. 1, 2, 3, 4, 5, 6, and in the middle 7.
Sure do, yeah. Sure do.
7 regions. So therefore, if you write this region separately, okay, how do I call them? So I call them, okay, on the left side, if you look at the picture, 3 sets, below that it's written, this part is 1, I go along the periphery 2, then 3, then 4, then 5, then 6, and in the middle will be 7. Okay, so 7 regions. Or maybe it's better, you see, I redraw it in Arabic, 1, 2, 3, 4, 5. Okay, let me just draw this one. Okay, 1, 2, 3, 4, 5, 6, 7. 7 regions. Okay, question is, if I shade one of those regions, how to describe every single region separately? Okay, so region number 7.
Okay, that
Okay,
would be A,
So this one is common
A,
part.
intersection B, intersection C. So that would
Good.
be A, U, B, U.
Not U, it's upside down.
A, right, A and, yeah.
Okay, in the book it's written maybe I instead of this. A, so the common part will be that one. Triple intersection, triple, all the 3. Okay, now I will, let me erase the double, and I will, after that I will write everything, otherwise I don't have enough room on the board. I erase everything, so. I will shade a region, and you have to tell me what is the formula.
Okay.
Okay, so I will draw small circles, and okay, this is the region. So how to do that? So you just shade it, and after that just draw the boundary to see that region, and after that shade again. So you see that clearly, right? Okay, how to describe this? Okay, that one. How to get this one?
So that would be, okay, hold on.
Yeah, so
A,
first of all, it's A, right?
right, A
But not,
minus,
but not the whole A.
it would be
You
A,
have to remove something.
A minus
Minus what?
A minus C. No, it's not. A minus B.
Now, if A minus B, if you remove A, if you have A minus B, you'll get this part, the big part. The whole part of C will be there as
It
well.
would be A minus B. No, A minus C.
If you take A minus C, it will be this part, including that one. It's not true. Okay, take scissors, and what you have to remove? You have to remove these two circles, right? Okay, let's look. So this circle together with this circle. If you remove these two circles, then you'll get this part.
Would parentheses be involved? Anything?
Yeah, so A minus parenthesis, right?
B minus
No, union C.
B union C?
Yes. B union C is B and C together.
Okay.
If you forget about A, if you forget about this boundary, okay, so this would be union C.
I see. Okay.
Got it?
Mm-hmm.
So therefore A minus B union C.
I see, I got you.
Got it? So if you understand that, let me ask you almost the same question. A, B, C, and so, okay, so this part. What is this part?
So that would be B minus parentheses
Parenthesis.
A union C.
C, right. Okay, why? Because if I take A union C, you see this one. Okay, this is the, so you have to erase, take scissors, erase it, so you cut it out, and look what will happen. You see? B minus B union C. And this is A union C, and you remove it. Got it?
Mm-hmm.
Okay, now the last question about that is, what is this one? So A, B, C. Okay, so what is this? So you start from what?
C.
C. And what do? Subtract, remove, minus.
So it would also be C parentheses A union B.
Very good. A union B. Okay. So we described three regions already in the same manner. You got it?
Yes.
Good. So now let's look what much is a little bit more complicated. So how about this one? So that region. Okay, the union of two regions. So this
Okay.
region and that region.
So that would be, okay, let me think about that for a second.
A, B, and C. So if you understand
What
that,
would
it will be very easy.
parentheses B union C.
No. First you take B.
Right.
You want to describe this part, so therefore you take B, as if it was the whole thing.
Okay.
From B you have to remove something.
Okay, B
Minus. Minus what?
A union C.
Now if you take A union C, so it will be this on the part. But you have to take, so if you take remove only A union C, you'll get this part, but not this part. Okay, that is more complicated. Do you know why? Psychologically. Okay, let's do the following. Remove this C at all. Okay, remove C. Forget about C. And what do you see? You have, so that part belongs to C, but you also could forget about this. Look at the picture. And you have this part. You have only two sets. It's B minus A, that's it. Okay, C is not, you do not need to touch C at all.
Oh wow, C's not even, wow.
Yeah, no, part of C is in here.
Right.
But if you forget about that, it will be B minus A, so forget, so as if C does not exist at all. So that part is actually, if you want to describe, you can describe in a different way. You can describe this way, that one plus that one. But that part is not described yet. On these pictures you have only this part, but what is that part in the middle, which involves C? We don't know.
Wow.
Okay, so but if you forget about C, once again, forget about C, so forget about this one, you'll get only two sets to B minus A, very easy. Okay, on the other hand, it's equal to B minus A union C, okay, from this part. And after that you have to union with this strange part which I redraw, but I don't know how to write it. So, and that part involves C, but how to describe this part? It's a different story. That part is easy. Instead of describe it separately, use the previous part. Okay, so let me just, okay, you see that this part. So, and from here, how to get this part? This part, let me just draw the picture again. And now we describe this part. A, B, C. Okay, how to get this one? B minus A is that part, equals that part plus this part. And we know that part already, this is that one, right? So we want to find that part. From here you can find this as follows, that region equals B minus A. Okay, this is B minus A, like if I surround. And minus that big part, B minus A union C. Okay. So it looks like this one, okay, B minus A equals that part plus that one. So therefore what is that? This is a difference between this and that, which I wrote, B minus A minus that part. But it's too complicated. It could be done much easier. This is true. But let's look, what is this part separately? So it's inside C, right? Okay, inside C. And what I have to remove? Okay, so what if I forget about B? And so what if I consider this part? Okay, so B is in here actually. If I take C minus A, I'll get the whole part, right? Yeah, so you're right. So I have to subtract this part as well, which is too complicated. Oh, I have another idea. Okay, let me draw once again. Okay. What if I take only B intersection C? What do I get? I get this part. And how to get this one? Minus the middle part. And you know, so B intersection C, okay, like the whole thing. So B intersection C is that one. And now I have to remove the middle part. What is the middle part? Minus the middle part, A intersection B intersection C. That's it.
Oh, that's not, okay.
Okay, so therefore what I erased before is the same as that.
Okay.
You have to find the simplest combinations to get this one. So you see that this part, okay, our part, shaded part, is a part of that figure. And that figure is B intersection C. So if you write B intersection C, it will be that part and something else. But this something else is simple. It's the triple intersection. So subtract it. Okay, all the parts are done in the same way. For example, tell me what is this? So suppose that one. A, B, C. What is this? How to write it down?
Okay, nope. A, and then you will print, would there be parentheses? Parentheses?
Okay.
A,
Tell me
Upside down U, I forgot what you call it.
Intersection.
Intersection C.
That's it. Because if you remove B, you will not touch this part at all, right?
Right.
So therefore, it depends on A and C, doesn't depend on B.
Mm.
Like here, where was it? Somewhere before. So like here, so C intersection B will be that one. It's a little bit more complicated. Minus the middle part, and here is the middle part is involved. Okay, and what else? So that one. You see, all the regions are described in the picture, and now we figure out okay, I highly recommend you to do the following. You see the formulas for each part, but instead of remembering it, okay, try to describe yourself each part. How would you describe? So what you have to unite, what you have to intersect, what you have to subtract, and if you don't know, then look at my formulas. For example, I show you only one example, and now it's 5 o'clock. We'll finish now with this one. Okay, because next time, unfortunately, it's too much material. I will take it for next time. Okay. So we just already hour and a half. So it's pretty long. No, okay. I want to finish with the one, and just the final point will be the end of the modulo 5.3.
Okay.
Okay, 3 circles, 3 sets, A, B, C, and we want to describe this part. Okay, the 3 of them all together.
Why?
Yeah. So okay, how to do that?
That would be A intersection.
Okay,
B.
so first of all, what is that? It's a union, right?
Yes.
And union this, that, and that. 2 unions. So
Right.
one thing, union this thing, and the other one, right?
Right.
Okay, one set, another set, and the third set. Now, what is this one?
It's A
Okay.
union C.
No. A union C is the big thing. So it's A intersection C
That's what I meant. A intersection
minus
C.
the middle part.
A intersection C
A.
minus A union B union C.
Yeah. Minus, no, not union, intersection.
Damn. Well, I was close.
Okay.
Okay.
Now after that, so this part. So we describe this one. A intersection C minus triple intersection.
Mm-hmm.
Okay, triple intersection. Let me just write here A. Let me omit intersection like write multiplication A B C. By the way, set theory is used in the probability theory. Well, we count the probability of events. You must draw Venn diagrams and then multiply, and then add probabilities, subtract and multiply. So intersection corresponds to the product. When you write A intersection B, it means you multiply probability A and probability B. So you can, let's do the following. Maybe it will be easier to remember. So you take AC, meaning common part in C, and minus ABC. But you have to write here intersection, intersection, intersection. Okay, after that you have to write union. The same thing. Now what is this part? A intersection B, AB, let's write B, and then minus again ABC. Minus the common part. From this part I remove the middle. And after that union, and what is the left part? The remaining, so that part is this one. Okay. And the last part will be what? C and D. I intersect C and B. Yes, CB. And minus again ABC. Okay, so this will be that part. And we got the formula. Pretty complicated, but it's written on the bottom of the page. Okay, look. But I used. Yeah, okay, so it's A intersection B. Look, A intersection B. So intersection B, and this is also intersection, intersection, intersection. Everywhere is intersection. Maybe just write I, okay, whatever. Like in your book. Okay, intersection, intersection. But also, okay, another set is in here. I think you'll figure out the last one, why it's the union. Okay, so that's it. I'm going to give you a home assignment later, based on what I told today. So this will be it. Okay, we'll finish for next time.